And from post-processing, you can also see the report. So let's say I can check the flux of the mass flow rate at the inlet outlet. And from here, I can check the solution convergence also, that it is giving me the error of the mass flow rate between the two conditions, two inlet and outlet, is around 10 power minus 11. So its solution converged fully. And also you are getting the value of mass flow rate, which is a 0.03127. And this is very correct because we have the 1 meter per second velocity, and from the area, which is around 0.0314, something like that, and density is a 1, so it should be like that. And also from the reports you can check the surface integrals, and from here you can have the, let's say, the area weighted average. For the static pressure, because it depends on the area, so I will choose area weighted average. For velocity, the total pressure, I will choose the mass flow rate, mass weighted average. So let's say if I want to see the static pressure at the inlet and outlet, there is the pressure loss along the pipe length. So I can go and see 6.91. So pressure loss is from 13.834 to the 0. And if I look at the post processing with the CFD post, which I have already explained in the lectures in this series, so you can go to the workshop number 1, and the section number is 10. So in this section, I have covered all these things which are shown in this slide, this PowerPoint file. These all things are covered there. So you just go there and you can see here. And here is the pressure plot in the CFX with the hexa meshing. And you can see here that at the inlet the pressure is 13.45 and at the outlet is a 0. And here we have the 13.83. So almost same values here also. And if we check the pressure gradient, this will be also equal to minus 1.6, maybe 1.67 or maybe 1.69. So they are almost same. The next thing is that I want to see the value of skin friction coefficient along the pipe surface. So when the flow is fully converged, so from the correlation for the laminar pipe flow, its value should be around 0.16. And from the CFX, the value of this one is around 0.1602. So I want to see the same value in the fluent. So you can perform that thing in the CFD post, which I've shown you already, and also you can perform same thing in the fluent, but in a different way. So first of all, I need to have the one line on the surface of the pipe. So this can be anywhere along the periphery of the pipe. So first of all, I need to create a plane, but this plane will be along the length of pipe. This can be along the axis, this can be along the y-axis. So this can be the zx plane or this can be the zy plane. It doesn't matter because the flow will be same along the both planes. So like this. So either I can go and get the plane along the z and the x in this way, or maybe up from the top to the bottom. So it doesn't matter, the solution will be same. So for that thing, I will go to the surface from post processing, and from here I will choose the iso surface. And if I don't choose any surface from here, and I just check the mesh, and from here x or y coordinate, this will do the same job. So I can create the one plane. So this one plane will be here in this way. This new x coordinate, which is 13 number, like this. In this way. And if I go for the y coordinate, this will also do the same job, but this plane will be normal to this existing plane of along the x direction. So I can display the y coordinate. So you can see they are both at the 90 angles to each other, like shown here. So the solution along these two planes will be same in this way. I can display the faces, and I can change the color to the, let's say, for the interior faces, which are here. Not the interior, but these are the internal surfaces. So let me try the color by ID. These two surfaces, they are normal to each other, so I can use one of them. So I want to just delete all these things again, and I want to create the fresh things from the scratch. So I will go and I will create just a y coordinate, doesn't matter. But this will create the whole plane along this whole section. But I want to just create the two lines along the wall of the pipe. So I will just choose the wall. So this will not create a plane along the whole domain from the internal side. This will just create the isosurface on the wall of your cylinder, which is shown here. This is the wall of cylinder. So no internal things here, only. So it means that when I take section here along the pipe dimension, so this will just create the two lines, one on this side, one second on this side. So it means that instead of getting one plane, I will get two lines here. So I will go here and I will, with the same setting, I will just click on the create. And now I want to show you that what is happening here. So I'm just getting two lines here instead of the whole plane. Okay. Next thing is that I want to convert these two lines to the one line only, because I just need this line or this line, and on the both lines the skin fraction coefficient should be the same one. So I can go to the manage again, to the create, and from here I will click on the iso clip. So this will just choose some dimensions within the range. So let's say I want to choose the y coordinate 8, and this is along the x-axis. So along the x-axis I want to keep only one line here. So I will go and click on compute and just choose any number here, like this, rather here, like this. So any number here, it should be on the any value here. So let me display the first this thing again. Okay, so we are at the y coordinate. Okay, so I will choose the x coordinate here for this plane and click on compute. So I will go for the any value here and click on clip. So this will choose a one line. So now I want to display this x clip here. This line is gone on the right side. This line is displayed here, and you can also do in the vice versa, and clip and display the 5 number clip here, and this line is now here and second line are gone here. And now from the XY plot I will go there, and because we have already set the reference values which I've said in the very beginning of the simulation, and because by formula we have the formula for skin fraction coefficient is the wall shear stress divided by the 0.5 density times exit velocity square. So in the formula of the same thing in the fluid is already there. So just you need to set the reference condition for the velocity, which is 1 meter per second. Density is 1 kilogram per meter cube. So that's why we have chosen the reference conditions, and now they will be used to calculate the skin fraction coefficient from the wall fluxes in this panel. So from here wall fluxes and then skin fraction coefficient, and then choose any one of them, and this show you the same value along these two lines. So you can just choose a one line here and plot it, and after that you can write the file. So let's say I put the name as skin fraction and click on OK to write down the file in the folder. So this file is here. You can right click here and edit with the Notepad++. It's a very good software. It's free to use. You can download it and you can install it freely. So from here you can see here that after some distance, which is when the flow is fully developed, so you can go after the maybe 2 or 3 meters. So after that you can see the value of the skin fraction coefficient is almost constant, and at the end of the pipe the value is this value is changing because of the tetra mesh. Value is a 0.1614, and the value we got in the CFX from the hexa meshing was 0.1602, and here's value is coming out to be the 0.161. So it's a very less difference here also. So if you get the hexa meshing results, so you will see that the value will be almost very much comparable with the CFS results, because this is more of the mesh than the solver. This is the end of this whole series on the laminar pipe flow in the Fluent, and I hope that this will be helpful to you and you will learn a lot of things here, and you can use them for your simulations in any other problem, because the basic things are same. You just need to have these commands, known how to use them, and how to solve the cases and how to compare results. Good luck.